break for the week. Okay, so here's some problems. Got a simple supported beam with a load P in the middle, and then a simple supported beam with a uniform load. So I'm going to draw the reactions here. I don't think it'd be too hard for you to figure out that the reaction on the left side is P over 2 up. Reaction on the right side is also P over 2 up. And of course there's no moments at the pins. And you can find that. So what this force that I drew here, this reaction that's up, what kind of shear force is that on the left side? Positive or negative? Positive. So I have a positive shear force of P over 2. On the right side, is this a positive or negative shear force?
Negative.
This is negative.
I was just about to ask you that.
So that'd be minus P over 2. So again, I know where I'm starting. I know where I'm going. So let's go back to our basic relationships. The change in shear is the area under the load curve. Now I've got this applied load here, so that basically cuts my structure into two pieces. A piece to the left and a piece to the right. So that's why I've drawn this additional line on my template. So looking at just the first section, L over 2, what's the load curve? If you had to write an equation for the load, what would it be? 0. And what's the area under a curve with 0 height? 0. So that means if I start at P over 2, I should end at P over 2. What is the slope of my shear diagram? Well, it should be the value of the load everywhere. What's the value of the load in the first segment? 0. So I have a curve here of 0 slope. So that says over the first half of the beam, shear is constant. Now as I go from the left side to the right side of this applied force P, what happens to my shear? It changes that amount. Does it change positive or negative? What kind of load is that? Positive or negative? Negative. So it's going to be a negative change. So if I have positive P over 2 and I subtract P, what do I get? Negative P over 2. Now the change between these 2 points is again the area in the load curve. And what's the load curve here? 0. So there's no change. So that's great. We matched. And the slope is equal to the load, and the load is 0. So 0 slope, straight line. So the value of the shear everywhere in this beam is P over 2. The left side is positive, the right side it's negative. All right, let's do the moment. Do I know the moment anywhere? What's the moment here? 0. What's the moment here? 0. Not much of a curve, is it? Well, there's something happened between those 2 points. And remember that we know the change in moment is the area under the shear diagram. So this part of the shear diagram is continuous. What's the area under this part of the diagram? It's a rectangle, so base, L over 2 times height, P over 2, that's PL over 4. So 0 plus PL over 4 gives me PL over 4. And I also know that the slope of my moment diagram everywhere is equal to the shear. So I come up here and look, what's the value of my shear of the first section? It's constant. It's P over 2, and it's positive. So I have a constant slope. And if I were to look at that value, it would be P over 2 height for a change in a 1. So now I'm looking at the second half of the structure. The change in moment is the area under the shear diagram. And what's the area of this part of the shear diagram? Well, it's a rectangle. P base, L over 2 times height minus P over 2. That's minus PL over 4. So positive PL over 4 minus PL over 4, 0. Great. And what's the slope? What's equal to the shear? Well, the shear everywhere there is constant. and it's negative. So here's a constant negative slope. If you looked at the change in shear from the left side to the right side, that would be the total area of the shear diagram, and you see both those areas cancel. You have no change. So you would start at 0, and you would end at 0. So you could do the whole problem, the whole beam, but you lose what's happening in between. I've run out of time today, so what I'll do is I think I'll hold off on this problem until we get together next time. So what I'll do is I'll publish this part and the video, and then I'll add to it next time. All right.